Let us consider the same two diode clipper in which the diode forward voltage V gamma is given. Okay, suppose V gamma is equal to 0.7 volts. Then plot the transfer characteristics. Okay, how do we do this? The same thing, procedure, everything remains the same. Just we change the input from negative peak to positive peak. Then what are the possible states of the diodes? Both one diode is on, other is off, or both are off, both are on. We have to see both are on, it's possible or right. All these cases, the same thing, right? So first case, suppose if I suppose I start with input is equal to 0, then what happens? D1 on, because cathode of D1 is at lesser voltage compared to its anode. D1 on. Once D1 is on, okay, keep it aside. And what about D2? The anode of D2 is going towards 0 and its cathode is going towards 4 volts. D2 is off. So the first possible case, case 1, as usual, D1 is on and D2 is off. So the equivalent circuit is this way. 2 volts, voltage across the diode D1 is 0.7 and D2 is off. V output 4 volts. So here if you observe this, D2 is no way connected to the circuit. Then what is our output? If I take the output, it is minus 0.7 plus 2, it is equal to 1.3 volts or output. Case 1. Instead of 2 volts, it is 1.3 volts. Okay. Next, case 2. Okay, how long this is possible? That thing also I have to write. Above circuit is valid if V input is less than breakpoint 1. It looks like 2 volts. Let us see. Less than some value. It looks like 2 volts, but we are not sure. Next, case 2. Both D1 and D2 are off. Input is greater than 2 volts and less than 4 volts. Then both D1 and D2 off. If both are off, two volts, 4 volts are V input, V output. From this circuit, what we can write? Output is equal to input. Okay. How long this circuit is possible? This circuit is possible if V input is in between breakpoint 1 and breakpoint 2. Possible or valid? Anything we can write it? Valid if breakpoint 1 less than V input less than breakpoint 2. Okay, this course is also fine. Next, if the input is greater than 4 volts, it looks like 4, right? Let it be. Then what happens? D2 is on, anyway D1 is off. So D1 is off and D2 is on. D2 is directed downwards. 4 volts, 0.7 volts. Input, output. It is 4.7 volts. output is 4.7. So here I can write above circuit is valid if V input is greater than breakpoint. Okay, that's it. These are the three possible circuits. Is there any other case possible? No. Now let us take the breakpoints. At breakpoint 1, what happens? At breakpoint 1, the overall system changes from case 1 to case 2. Okay. So at breakpoint 1, what we can write? V output is equal to 1.3, which is of course equal to input. So implies our breakpoint 1 is equal to 1.3 volts. I can take. Next, at breakpoint 2, output is equal to input, point of intersection of case 2 and case 3. It is of course equal to 4.7 volts. Implies breakpoint 2 is equal to 4.7 volts. That's it. We have got the two breakpoints. Okay. Now let us draw the transfer characteristics. If I draw so, one equation is output is equal to 1.3 volts. Second equation is output is equal to input. Third equation is output is equal to 4.3 volts, 4.7 volts. So the first point of intersection, it is breakpoint 1, whose value is equal to 1.3 volts, and the second breakpoint is 4.7 volts. So if V input is less than breakpoint, case 1 is possible, in which output is equal to 1.3 volts. Less than 1.3, maybe positive or 0 or negative. That's it. Input is less than 1.3 volts. Output is 1.3. If input is in between 1.3 volts and 4.7 volts, case 2 is possible. Output is equal to input. And third breakpoint, after the second breakpoint, after 4.7 volts, input is above 4.7 volts, output is equal to 4.7 volts. That's it. This is how the things change. Okay, instead of 2 and 4, we are getting 1.3 volts and 4.7 volts. This is the idea. And one more point, in the same circuit, if you see, just to confuse us, they may give the circuit even this way also. Both are one and the same, 4 volts. They may give the circuit this way. Then what about the transfer characteristics? Maybe ideal or ideal diodes or V gamma may be given. But what happens? This combination, right? They may give D1 and D2. Then wherever, right, ultimately the operation remains the same. Wherever you have D1, you write D2, and wherever you wrote D2, there we write D1. That's it. Okay. This is the idea. Just because this D1 parallel with 4 volts is parallel with D1 in series with 4 volts is parallel with D2 in series with 2 volts. That's it. To confuse us, they may change the things. What you have to remember, the diode directed upwards should be at a lesser voltage, connected to a lesser voltage compared to the diode directed downwards. That's it. The change. According to our notation, it is D2 and it is D1. That's it. Okay. With this, you can take different combinations. Instead of 4 and 2, I can take even different combinations. Like both need not be positive. One is positive, other one is negative, or both can be negative. So let me take one such combination. You see, suppose I have a clipper circuit like this. Some 3 volts, 1 volt, D1, D2 are input, output. Maybe ideal diodes or V gamma is anything, doesn't matter. We know how to take the calculations. Suppose the diodes are ideal. Then what we can do? Just like that. So if you take the transfer characteristics, how do we get it? One breakpoint is minus 1 volt, another breakpoint is 3 volts. And the result I'm directly writing here, output versus input. V output is equal to minus 1. This is one graph. And output is equal to okay. Output is equal to input, and third one, output is equal to 3 volts. Then what about our breakpoints? This is breakpoint 1, minus 1 volt, breakpoint 2, 3 volts. So input is less than minus 1, output is equal to minus 1. And input is in between minus 1 and 3, output is equal to input. And input is greater than 3, output is equal to 3 volts. That's it. This is how we can write it. So just once you know these two values, based on that, we can write it. Again, if V gamma is given as 0.7, then it becomes minus 1.7, breakpoint 1 becomes, and breakpoint 2 becomes 3.7. That's it. If V gamma is equal to 0.7, then breakpoint 1, it becomes minus 1.7 volt, and breakpoint 2 becomes 3.7 volt. That's it. It is as simple as that. And both can be negative also. Based on this transfer characteristics, we can even write the waveforms. Not at all an issue. And suppose in the same, right, similar circuit I'm taking here. For our understanding purpose, I am writing here D1 diode directed upwards is written first. Right? It is not mandatory. Suppose it is connected to minus 4 volts. D1, D2 are input and output. How do we get its transfer characteristics? In between minus 4 and minus 1. Just you need to check it whether the diode directed downwards, upwards is at a lesser voltage compared to the diode directed downwards. Yes, it is so. So what about its transfer characteristics? One equation is like V output is equal to minus 4 volts. Another equation is output is equal to input. And one more is V output is equal to minus 1 volt. Then the breakpoints. Breakpoint 1 minus 4 volts. Breakpoint 2 it is minus 1 volt. So this is how we get ideal diodes I'm taking. This is for a case of ideal diodes. Then how about the output waveform? You will be getting the output in between minus 4 and minus 1. Output maximum is minus 1 volt, output minimum is minus 4 volts. So a particular portion of the input is passed through this network, and output has a maximum of minus 1 volt and a minimum of minus 4 volts. That's right. This is how we can analyze the circuits. The next one. Okay, this is fine. The very basic clipper circuit, two diode clipper circuit. The moment you see the circuit, just like that, you can put the answer. Okay. If Vegam is gone, based on that. Further, what I am doing is, let us start with the basic example only, or I would like to change it otherwise. Not an issue. 1 volt, 3 volts, D1, D2, R. In this circuit, suppose one more resistor is connected. Maybe 1K, both the resistors, maybe 1K or 5K or 10K, something like this. Then how do we do this? Okay. Take the three possible cases. Like first D1 is on for input less than breakpoint 1. D1 and D2 off, above breakpoint 1 and below breakpoint 2. Next, above breakpoint 2, D1 off, D2 on. These three cases as usual. Case 1, D1 is on and D2 is off. Ideal diodes I am taking for time being for better understanding. It acts as short circuit. D2 acts as open circuit. Then what is output? 2 volts. Okay, doesn't matter. We can keep it aside. And above circuit is valid if V input is less than breakpoint 1. It looks like 2 volts, but we are not sure. Next, case 2. D1 and D2 both are off. Then this is our circuit. Then what is the output? Is it possible to write output is equal to input? Definitely not. There is a current flow. So output is equal to V input by R plus R into R, that is input by 2. Anyway, Half of the input is across this resistor and another half is across the resistor. 2 volts and 4 volts, they do not play any role. They are no way connected to the circuit. Just like that. We can take it. Instead of output is equal to input, we are getting output is equal to input by 2. And above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. It looks like the breakpoints are 2 and 4. But don't take them as granted. Time being, I am writing breakpoint 1 and breakpoint 2. Okay. Then case 3. Input is above. Oh, sorry friends. It is a 1 and 3 volts. No. Very sorry. Okay. Anyway, I am not writing the breakpoint values. Right. Procedure remains the same. Okay. So D1 is off and D2 is on. How about the equivalent circuit? What is output? It is equal to 3 volts. Then this circuit, if input is greater than breakpoint 2, that's it. Now let us find the two breakpoints. At breakpoint 1, or even here also I can write. Okay. Let us take it in the next phase only. At breakpoint 1, it is a combination of circuit 1, case 1 and case 2. Output is equal to 1 volt, also equal to input by 2. Implies breakpoint 1 value, it is equal to 2 volts. Right. And at breakpoint 2, output is equal to input by 2, which is also equal to 3 volts, implies breakpoint 2 value is 6 volts. Okay. So if you draw the transfer characteristics of this particular case, output is equal to 1 volt. Output is equal to input by 2. Slope is coming down here. And third one is output is equal to 3 volts. Breakpoint 1, it is equal to 2 volts. Breakpoint 2 is equal to 6 volts. This is how we can see the transfer characteristics. Okay. So what happens if input is in between 1 and 2 volts is my concern. Here up to 2 volts D1 is off. Sorry, D1 is on, D2 is off. Between 2 and 6 D1 D2 off. Above 6 volts D2 is on. Let me check it. What happens if the input is in between 1 and 2 volts? Okay, just out of curiosity I'm doing. Anyway, this is the general procedure and we are getting the result. No doubt about it. But students may be getting a doubt like, yes, what happens if the input is above 1 volt and less than 2 volts? Why D1 is not conducting is my concern. Okay. And if the input is more than 3 volts, maybe 4 volts or even 5 volts, why D2 is not conducting? Right? Input may be greater than 3 volts, maybe 4 volts or 5 volts. Why D2 is not conducting? D2 also has to conduct, no? Because it looks like its anode is at a higher voltage compared to cathode. Let us check those cases as well for better understanding of the concept. Okay. Just out of curiosity I am doing. Let us consider, suppose input is equal to 1.5 volts I am taking. Okay. So 1 volt, 3 volts resistor R. Okay, suppose input is 1.5 volt. Then it looks like D1 has to be off. Okay, and D2 is also off. It looks like D1 and D2 are off. If so, what is our output? What is the equivalent circuit? Tell me. Output is equal to input by 2. And what is your input? 1.5 or 1.6 I am taking. Just to make my calculation simple, nothing else. Then it becomes 0.8 volt. First of all, what is the output minimum we have noticed? If D1 is on, output minimum is 1 volt. Where do you get this 0.8 volt which is less than 1 volt? Impossible. If for input is less than breakpoint 1, D1 is off and output is 1 volt, right? I cannot get output of 0.8 volt. Output minimum is 1 volt. Suppose, okay, if D1 and D2 are off, you are getting 1.8. It is a conflict. It is not possible. Suppose I take this 1.8. What is the voltage at the anode of the diode D1 then? Cathode of the diode D1. Cathode is at 0.8 volts and anode of D1 is at 1 volt. Ideal diode. So anode is at higher voltage compared to cathode. D1 has to conduct. Means once D1 is on, output is equal to 1 volt. Is it sorry, is it possible to take D1 is off? No. See the interesting thing. Why it is happening so? Right? If you assume D1 is off also, then there will be a current flow in this way. And out of 1.6 volts, 0.8 volts is here, 0.8 volts is here, and another 0.8 volts here. Okay. Or right? Anyway, voltage at the cathode of D1 is 0.8. Earlier there was no current flow and there is no voltage drop across this resistor, and hence entire input can be seen at the cathode of the diode D1, which is not happening so here. The cathode of D1 is at a lesser voltage than input. Okay, and how much it is? 0.8, which is sufficient to see that D1 is on. This is the effect of the additional resistor connected across the output terminals. This kind of analysis we have seen even with a single diode clipper circuit. I hope you understand it. This is the idea here. Okay, and you can even check it, right? Suppose D1 is, I told you D1 is on and D2 is off. No doubt about it. So, two volts are input, output. Okay. So there will be a current flow ID1. I can write ID2 is anyway 0. What is that ID1? We can calculate it if I know the resistor values. For time being, I'm writing 1K, 1K. You can write 10K, 10K also, doesn't matter. Just equal resistors, that's it. Then what we can do is D1 is on. Let us find those currents. V input, and V input is how much? It is 1.6 volts, right? For 1.6 volts I'm taking. So diode current is coming like this, and output is 2 volts as D1 is on. So there is a current flow. And what about this current? Let me take this current as I2. Okay, and this current as I1. Okay, so what about I1? I1 is equal to, here output is 2 minus 1.6 by 1 kilo ohm, it is 0.4 milliampere. And what about I2? We output by 1 kilo ohm, that is 2 milliampere. Then what about ID1? ID1 is equal to I1 plus I2. Okay, two currents are leaving this node and one current is entering. ID1 is entering, I1, I2 are leaving. So it is 2.4 milliamperes. The current through D1 is positive, means 100% D1 is in conduction. However you take, we can analyze it. Oh, sorry, there is a mistake again. Sorry. It is 1 volt. If that is the case, I should change the things. Anyway, ID1 is like this, and output should be 1 volt. Then I should change the direction of the current I1. I1 should be like this, and I2. What is I1? 1.6 minus 1 by 1K, 0.6 milliampere. Okay. Then what about I2? I2 is V output by 1K. It is 1 milliampere. What about ID1 then? I1 plus ID1 is equal to I2, or ID1 is equal to I2 minus I1. It is 0.4 milliamperes. That's it. Very sorry. It's a simple calculation. Okay. So you can even think this way also. Okay, it's not like a cathode of D1 is looking like at a higher voltage compared to anode of D1, but things change because of the presence of this resistor. That's what we have been observing with respect to diode circuits with respect to DC or single diode Clippers as well. This is very, very interesting. If they give V gamma, doesn't matter. Procedure remains the same. Okay, that's it. This is one case. Next, suppose the input is greater than 2 volts and less than 4 volts. Okay, breakpoint 1 is 2 volts. Another breakpoint we got is 6 volts. So between 2 and 6, what I would like to take is less than 3 volts I am taking. Okay, and above breakpoint 1 and less than 3 volts. What happens? Okay, there we can understand like suppose I take the same circuit. Let me write these values first, otherwise okay. So input is greater than 1 volt or less than the breakpoint we have seen. Okay, breakpoint 1 is 2 volts and I took a value just below 2 volts greater than 1 volt. Why the diode D1 is still on, we have observed it. Done. Next, breakpoint 1 is 2 and between 2 and 3 what happens? Absolutely both D1 and D2 are off. I need not do it anyway. Let me take a value more than 3. Okay, suppose here I am writing V input is equal to 4 volts. Actually breakpoint 2 is 4. Sorry, 6. I am taking a value more than 3 but less than breakpoint 2. That's what my concern is. Then what happens here? Anyway D1 is off. It looks like D2 is on. It looks like D2 is on. Anyway D1 is 100% off and it looks like D2 is on. Then let's assume D2 is on. If that is the case, we know the regular procedure. Just to calculate the current through the diode D2, which should come positive. Ideal diode I am taking 3 volts. R and R, right? Let me take some 1 kilo ohm like this. Okay, I am taking 4 volts here. So input is equal to 4 volts. Then as D2 is on, there should be a current. This is ID2. Okay, and this is I2 for 1. So let me take this current as I1. Okay. So what about I1? 4 minus 3 by 1K, it is 1 milliampere. And what about I2? 3 by V output by 1K, it is 3 milliampere. So what about ID2? Is it so? ID2 should be positive. If ID2 is positive and ID2 plus I2 is equal to I1, which is less than ID2, is it possible? No. So if I take ID2, it is I2 minus I1. Sorry, I1 minus I2. I1 minus I2. So which is found to be minus 2 milliampere. Negative not possible. If the diode is on, current from anode to cathode should be positive. You are getting it. Means my assumption is wrong. Is it not so? So which means D2 is also off. Implies D2 is also off. If D2 is off, what is the equivalent circuit, friends? Output is equal to input by 2. And what is the input in this case? 4 volts. As input is equal to 4 volts, output should be equal to 2 volts. If output is 2, the voltage along this line will be 2 volts. Then look at the diode D2. If you look at the diode D2, the anode is at 2 volts and the cathode is connected to 3 volts. How is it possible for D2 to conduct? Definitely not. This is the actual scenario, right? We have got right for 4 volts, which is looking like anode of D2 is at higher voltage compared to its cathode. D2 should on. If that is the case, if you calculate the diode current through diode D2, which is coming to be negative, means anode of D2 might be at a lesser voltage compared to cathode. D2 is off. Then we have cross verified that also. The anode is at 2 volts, cathode is at 4 volts as far as D2 is concerned. Okay, you can check it up to 3.8. If we input, sorry, 5.8. If input is 5.8 volt, then output will be equal to 1.9 volt. So then the anode of D2 is at 1.9, 2.9, 5.8 means 2.9. Anode of D2 is at 5.9, the 2.9 volts, and the cathode is at 3 volts. 100% D2 does not conduct. When will D2 conduct? D2 conducts if input is greater than 6 volts. So these are all for our understanding purpose. But in the exam, you need not cross-check all those things. You just blindly follow the procedure we have discussed and trace the breakpoints. Who will do, right? For my understanding purpose, I took simple examples like I took equal resistors. And the exam, they may not give equal resistor values, something else. One is 2K, another is 7K, some values, 5K and 8K, something like that they make you. Who will break the head for finding the breakpoints using trial and error method? I took some values randomly, right, above and below breakpoint to see, conclude that our analysis is apt. Okay, this is how we do this problem. Okay, that's it. Whatever may be the resistors, you can just go with the procedure. Such a strong procedure we have developed. Take the possible circuits. From each possible circuit corresponding output equation. Solve the output equations for breakpoints. Once you get the breakpoints, over, everything is done. Let us do some problems asked in previous papers. Right here, I forgot to write the year in which it was asked. Doesn't matter. See this. The function of the following circuit if the input is a sine wave. Of course, they should mention a sine wave of what amplitude, right? Transmits the part of the sine wave which is above 8 volts and below 4 volts. Transmits the part of the sine wave which lies, sorry, there should be some printing mistake. Right, anyway, what is the answer? Check it. If you see the things, diode directed upwards is taken here. it is connected to a lower voltage compared to the diode directed downwards. It is connected to 8 volts. So if you take its transfer characteristics, what you can write, output minimum, it is equal to 4 volts, and output maximum is equal to 8 volts. So transmits the part of the sine wave which lies above, or which lies between 4 and 8 volts. Option B is correct. Okay, it's a very, very simple thing. The moment you see the question, just like that, we can answer. Right? That much exercise we did so far. Next question. Yes, two resistors, equal resistors are given, and V gamma is also given. Doesn't matter. Ideally, what you can write, breakpoint 1 is -1, and another first breakpoint, diode direct upward, it is connected to -2. Fine. Diode directed downwards, it is connected to -1. Actually, what do you expect? -2 to -1. That is our expectation. But because of this resistor, the breakpoints, V input 1 becomes, breakpoint 1 becomes -4, breakpoint 2 becomes -2. Okay, -4 and -2. But we have, right, it is given that voltage drop, forward voltage drop is given as 0.7. So what to do? Absolutely. So first let us find those breakpoints, or V output minimum, or V input less than breakpoint 1. I did not write all those things. It's a simple thing. If V input is less than breakpoint 1, okay, output is equal to how much? It is minus 2.7 volt. Okay, and breakpoint 1 less than V input less than breakpoint 2, then output is equal to input by 2. Next, if input is greater than breakpoint 2, then what happens? This diode is on, this diode will be off, and output is equal to minus 0.3. I'm directly writing the answers because we are well aware of it. Okay, output is 0.7 plus, minus 1. It is equal to minus 0.3 volts. Okay, that's it. So if you observe this, we can see that option minus 2.7 less than VI less than minus 0.3. But what happens here? Is it true? So no, because here, if the resistor 10K is not present, then option D is possible. Okay, we should be very careful. In between, we have V output is equal to input by 2. So at breakpoint 1, what we can write? Output is equal to minus 2.7 is equal to input by 2, implies breakpoint 1 is equal to minus 5.4 volt. Here only we can see option C. This is the range of input, no? Okay, if input is in between minus 5.4 and at breakpoint 2, output is equal to input by 2 is also equal to minus 0.3, implies breakpoint 2 is equal to minus 0.6 volts. So option C is correct. That's it. Okay, this is the answer. Then next question. Assuming the diodes to be ideal in the figure, for the output to be clipped, the input voltage Vi. Okay. Ideal diodes they are saying. What about the breakpoints they are asking indirectly? For the output to be clipped, what is the value of VA? Okay, we are well aware that initially diode directed upward is at a lesser voltage compared to the diode directed downwards. Fine. Some resistor is given. No issues. Initially what happens? Let me take this is D1 and D2. This as D2. D1 is off, D1 is on and D2 is off. Case 1. So what is our equivalent circuit? The equal resistors anyway 10k they give, doesn't matter. 4 volts. If this is the case, what is the output equation? There is a current flow like this, and output is equal to input minus of minus 4 by, I'm writing R plus R because R value is anyway 10k. Okay, that is the voltage across this 10k. Okay, what is the current? Input minus of minus 4 by sum of the resistors multiplied by the resistor gives us voltage across this R, and for which I need to add minus 4. So how much do I get here? It is V input by 2 minus 2, because it is plus 4 by 2 means plus 2 minus 4, it is minus 2. Okay, this is what we can observe. It's not like output is equal to minus 4, right? Output is given by this equation. And second case, case 2. Let us take it to the next case. So above circuit is valid. Let me write the statement also. If input is less than breakpoint 1. Okay. And input is above breakpoint 1 and below breakpoint 2. Both D1 and D2 are off. What about output? Output is equal to input. And above circuit is valid if breakpoint 1 less than input less than breakpoint 2. Okay, this is also fine. Next, case 3. D1 is off but D2 is on. Output is equal to 4 volts. The interesting thing here is we are not getting output is equal to minus 4. Okay, if this resistor is not present, then we might have seen output is equal to minus 4. Are you getting output is equal to minus 4? No, we are getting output is equal to V input by 2 minus 2, one equation. Okay, second equation is output is equal to input. Third equation is output is equal to 4 volts. Above circuit is valid if V input is greater than breakpoint 2. That's it. Okay. Then at breakpoint 1, let us find the breakpoints. Output is equal to V input by 2 minus 2 is equal to input. Implies, what do we get? V input is equal to minus 4 volts, which is our breakpoint 1. So interestingly, it is minus 4 only. So great. Next, at breakpoint 2, output is equal to input, which is equal to 4 volts, implies breakpoint 2 is equal to 4 volts. Breakpoints are not changing, but the case 1 equation, output equation is changing. V output is not equal to minus 4. Instead, it is V input by 2 minus 2. Okay, the equation we are getting a different one instead of minus 4. Okay, but the breakpoint values are not changing. Breakpoint 1 is minus 4 and breakpoint 2 is plus 4. Okay, so for the output to be clipped, the input Vi, right, one is at a minus 4 and plus 4. This is how we can analyze this problem. I'm not taking some intermediate values, what happens, etc., etc. Not required. If you are interested to cross check, you can do it. It's left to the students. Next question. Okay. Right. It was a question asked in GATE Electrical Engineering 2003. Okay. 20 years back. A voltage signal 10 sin omega t is applied to a circuit with ideal diodes is shown in figure. The maximum and minimum values of the output voltage waveform V output of the circuit are. What about the maximum and minimum values? It's a very simple thing. When input is minimum, the corresponding output is also minimum. When input is maximum, the corresponding output is also maximum. So, nice, simple. So, directed upward D1, directed downwards T2. Okay. So I can write if V input minimum, what is V input minimum? 10 sin omega t means minus 10. If V input is equal to minus 10 volts, then definitely D1 is on and D2 is off. As they mentioned ideal diodes, what is the possible circuit? Already we have analyzed this circuit. So what can we do here? Output is equal to, okay, what is the equation? Already we have written that, right? Input by 2 minus 2 I have written. I'm using that because previous problem we did. But what is input here? Input is minus 10. So minus 10 by 2 minus 2, it is minus 7 volt. Where can you see? Yes, minus 7. Option D is correct. Blindly we can take it. Anyway, let us do the things. When input is minimum, corresponding output is minimum, whose value is minus 7 volts. Okay. Then if V input is equal to plus 10 volts, then what happens? D1 is off and D2 is on. What is output? 4 volts. Input may be 10 volts. Doesn't matter. So output maximum is 4. We are getting it. So that's it. Okay. It's a simple thing. Right. See this. A voltage signal 13 sin omega t is applied to the circuit with ideal diodes is shown in the figure. The breakpoint values of the transfer characteristics are. What about the breakpoints in this particular case? See, here some 10K is given, nothing else. Right, instead of 4 and minus 4, it is show, right? It is a minus 2 and plus 2 volts. We know all those cases. Okay, so case 1, D1 on, D2 off. Okay, yes, this is the circuit. What is the output equation? Possible circuit is this, and this 2 volts is no way connected to the circuit. We can take it out. Let us take the node equation. Let me take it as node A or node X. Anything you can take. KCL at node X. Let me write it in the next page. What we can write? V output minus V input by 10K. V output by 10K. And V output minus of minus 2 by 10K. Okay. V output minus V input by 10K plus V output minus of minus 2 by 10K plus V output minus 0 by 10K or V output by 10K. We can write. Anyway, 10K I can take it out. V output plus V output plus V output. It is 3V output is equal to V in minus 4. So output is equal to V input by 3 minus 4 by 3. This is the first equation. Okay. Second thing, case 2. Okay, above circuit is valid. Even we can write that not required. If V input is less than breakpoint 1. Next, case 2. Both D1 and D2 off. Okay. From this circuit, what is V output? V input by 2. Above circuit is valid if breakpoint 1 less than V input less than breakpoint. Okay. Then case 3. D1 is off and D2 is on. Output is 2 volts. That's it. Then what about the breakpoints? At breakpoint 1, I can write output is equal to input by 3 minus 4 by 3. It is equal to input by 2. Okay. So implies V input by 6 is equal to minus 4 by 3, implies breakpoint 1 it is equal to minus 8 volts. Okay, straight away I am writing it. Next, at breakpoint 2, output is equal to input by 2. It is also equal to 2 volts. Implies our breakpoint 2 is equal to 4 volts. That's it. Minus 8 to 4. Okay. It's not like minus 4 to plus 4. Is it not so? This is the interesting thing here. That's it. Any problem you take. I'm not changing the procedure, first of all. If I keep on doing the problems, right, or if I keep on changing the procedure from problem to problem, definitely you will be in trouble. And the exam, we should go with the best possible method. That's very, very important, which saves our time like anything. Okay. We did enough exercise. Okay. Let us do some more problems.